In this tutorial, we're going to learn to build the Accretion project, which exists as a demonstration project. We're going to see the techniques, though, to create it, as well as techniques that are used in other kinds of constructions for both games and science models. We'll start with the basics, and then we'll add additions for embellishment, as well as tools for monitoring what's going on in the Accretion model. So first, we're going to create something that will generate the particles that it will eventually stick together. So we're going to create now some people might call this a floor or a background. We're going to call it generator because that's what it's going to do. It's going to generate particles. We're going to make it a tile. And I'll choose just one of my favorites. And now we can go to the code. We're going to place one tile in the lower left corner. And we're going to use a technique that's very useful for creating large numbers of cells completely covering a layer. Rather than try to use the multi-layer insertion tool, which is next to the pencil tool in the toolbar, we're going to have this particular agent generate itself. So the first thing we'll do is establish a simulation property to control this. So we will open the simulation properties window and we'll add a new simulation property called build mode. Let me just capitalize it, although it's not necessary. And I'll save it. Remember that simulation properties are saved independently of the world, but they are restored to their last saving when the world is reloaded. The build mode is going to control construction modes. It'll eventually control the simulation, but not initially. In the code, we will say if the cell to my right is empty, we'll make a new generator cell, but only if the build mode has a certain value. So we will test. And in the simulation properties table, we just use the name of the simulation property, but when referring to it in behavior, we have to reference it with the @ sign. So @ build mode. When that's equal to 1, and the cell is next to it on the right is empty, we'll make a new one. We'll also do the same thing if the cell above it, and by above it, in the same plane, we'll make a new cell above it. Now, when we single step, you can see what happens. First, I set the build mode to 1, and then I could run it, but I'm going to single step. We can see it building all the way to the end. If I look at the state, I'll stop the simulation. If I look at the state of the cells, either at the far right, we see that it's not empty above or to the right, and all the way at the top, it's the same. So these rules will no longer work, even though the simulation is running. Let's save this. And when I reload the world, we see the build mode is back to 0. Well, now what we want to do is create multiple layers. Again, we could do this manually. We have to actually create the grid for those layers manually, but in terms of filling them, we can have AgentCubes do the work for us. So first of all, I want to bring up the layers panel, and I will let's add 3 layers. 1, 2, 3. You can see that the grids appear. We'll have to zoom out a little bit and tilt the camera to see the construction. And I'm going to actually close these layers down a little bit. So now we can see that I've got a 4-layer system. Keep in mind that the coordinate system for AgentCube starts with 0, 0, 0 as the origin. So the lowest layer is layer 0, which we'll probably refer to as the first layer, but it's layer 0. The leftmost column is column 0, and the lowest row, which is closest to the screen, so to speak, is row 0. So the upper layer at the upper right cell in that upper layer is layer 3, column 15, because there are 16 columns, row 8, because there are 9 rows. I'll save this. And now what we want to do is have the floor, or the generator agent, the thing that's at the bottom of the lowest layer, propagate itself up. Let me get a little bit more space for code. I'm going to add another rule. And this time I'm going to say, if the cell not above me in the sense of in the same plane, but directly above me in the next layer. In the expanded conditions, the in-layer option refers relatively to the layer that is being considered. So I can either put +1 or 1. I'll put +1 for emphasis here, just to show that I'm referring relatively one layer above. The relative mode refers to first-person navigation, has nothing to do with what we're doing today. So don't be confused by the relative mode option in conditions and actions. And in this case, I want the build mode to be 2. So I'm not going to worry about propagating the floor within a layer, but propagating it up. I will make a new, notice I'm pulling actions and conditions not from the palettes, but from the rules above. That copies when you do that. In this case, I want it to be in the layer above me. And I'll just put a 1 here to show that +1 and 1 mean the same thing. Now, when I run the simulation, nothing happens until I set this build mode simulation property to 2, and then you instantly see that it's been propagated all the way up. And I'll save this. And when I reload the world, build mode is back to 0, and I have my world created. So that's a technique that's very useful to use in many other kinds of projects. The next thing we want to do is create particles. So I'm going to go back to the gallery, make a new agent. I'll call it particle. We're going to use spheres to represent our particle, and the color option lets us choose different colors that are solid. I'm going to choose the gray color for the particle, and we'll see why in just a bit. And then I need to create another shape for this particle. The gray particle is going to be the moving particle, and when I create another shape, I'm going to call it, well, I'll just call it fixed particle. And I'll abbreviate it a little bit so that the names show up in tables without missing some of the characters. Now it looks the same, but now I'm going to change it to be a different color. Going to make it a sphere, a color, but it's going to be white. We can see in the table that it looks significantly different. In the world itself, it'll look not quite as distinguished. Now we have this, oh, what did I do? I changed the wrong one. Well, always remember that you want to choose the one you want to change first. Well, I'm going to change this one back to the white one. That's the fixed one. And I'll go back to this one and make it gray. Sometimes I do this deliberately and see if my students catch the error and claim it was a test. But now what we have is something called fixed particle and another one called particle. We could leave it alone. It doesn't make a lot of difference, but I'm going to change the name of the shape. I'm going to call it moving particle. It warns me that it's going to change it throughout the simulation. And that's fine because we haven't done anything that we need to be concerned about. So now I have 2 particle shapes in the class of agent called particle. Well, that's an option. You don't have to do it, but it's always good to be able to distinguish the agents and methods and variable names so that they really mean what they are. What do we want to happen? Well, in the code, we would like moving particles to move. And we want them to move randomly throughout the entire world, so not just in a plane. So let's tell the moving particle, if you're a moving particle, we do that by saying, if the agent in this cell, people often talk about, if I see myself as, it kind of anthropomorphize it, but if the agent in this cell is a moving particle, then we want it to move randomly one cell. Now, there are some options here that later we're going to select. We don't want it to stay in the same layer. I mean, we don't want it to, we'd like it to move only on empty cells, but we can't do that when we're initially testing because none of the cells are empty. They all have these generator agents in it. But later, when we want the model to not let particles move on top of each other, we'll click this option here. But for now, we can't do that. Okay, let's just test it. It's always good to test incrementally. So I'll put a moving particle and make sure I've chosen the moving particle. Yep. We'll put a couple of moving particles here on the different cells. And let's watch them move around. We can see they're jumping down, moving out among the different layers. Great. So let me reload the world. There are no moving particles. And let's put a fixed particle in and see that it doesn't do anything. So I'll go back to the gallery, put a fixed particle in, take my pencil tool, put one there, run the simulation. Nothing happens. So far the code is doing exactly what we want. Let me stop and reload the world. What do we want to do next? Well, what we'd like is for the particles to stick together. When a moving particle reaches a fixed particle, we'd like it to accrete, to stick to that particle. So we need some behavior that says, what happens if I'm next to a fixed particle? Well, we can make a new rule. And we still want this to only be the case when it's a moving particle. But we want it to be if it's next to at least one fixed particle. We'd like it to fix. We'd like it to get stuck. Well, how do we do that? We'll just change its shape to be a fixed particle. No problem so far. And let's see why this doesn't work. I'm going to put some moving particles, and I'll just put a bunch of them here. So it's going to be real clear that at some point they'll get next to a fixed particle. And we'll see what the problem is. And now I'll run it. Now we know that there's something next to the fixed particle, but it's not sticking. And why is that? This is where rule order is important. If our conditions are mutually exclusive, it makes no difference what the order of the rules is. But in this case, they're not mutually exclusive. In the first rule, we see that it's asking, is this a moving particle? And the answer is yes. If that's the case, even though it's next to a fixed particle, and let's, for example, see what happens when I do this. I'll put a fixed particle right here, and I'll put a moving particle next to it, right there. If I now select that moving particle, we can see that the first rule is the one that's going to run because the conditions are all satisfied. We'll never reach this rule. So this is a case where rule order is very important. If I just simply move this rule up, now what do we see? Now that rule has all of its conditions satisfied so that it will stick. If I move this particle a little ways away, now it'll run. And let's just prove it. We'll move it here and run. And we see more and more particles sticking. And let me run it really fast. And this is interesting what's going on here. Let me stop the simulation. I'm going to slow this down so we can use it in the future. What's happened? We asked the particles to move around randomly across layers, but they all got stuck on the bottom layer, and they got stuck on top of each other. So, well, we're going to have to address this a little bit later. We have more work to do here. But first, before we do that, let's see if we can find out how the particles are sticking together. We're going to say that we want to color the particles in the order in which they stick. So now let me reload the world. Well, before to do that, let's generate some particles automatically. Let's make the generator do its work and generate particles. How are we going to have it generate? Well, what we want to do is have the generator agents generate particles randomly with some kind of density. So first thing I want to do is add a new simulation property called density. And let's set it to, say, 5, which is going to become a percentage. Remember, I need to save the simulation properties independently of saving the world. And what we want to do now is we want to have the generator generate particles if there's no particle in that cell. And we want to do it randomly. And we want to do this only if the build mode is not in a run situation. So we're going to have the generator now have a way to generate particles when the build mode is 3. Well, that's one way to do it. And I could put this in the while running method. But that would make him continue to generate particles. So what I'm going to do now is make a new method. I'll call it generate. And I don't really have to test the build mode as 3, but this is going to make it real clear that there are different kinds of construction modes. So I'm going to say if the build mode is 3, sort of makes me keep track of what I'm doing. And if the cell is, there's no particles sitting on top of me. So I'm not stacked. And we do that by saying not stacked somewhere below. It could be immediately below or somewhere below a particle. And notice what I did is I chose the stacked condition. The stacked condition refers to a particle class. So whether it's a moving particle or a fixed particle, this says if I'm not stacked below, that is, there's no particle already above me, then with a percent chance, and here's why we'll bring in the @ sign density, I will make a new, I'm going to actually drag it from over here so I don't have to change the operands. I will make a new, in this case, particle in this cell, a moving particle. Now, I'm going to set the build mode temporarily to 3. And how do I invoke this? Well, we're going to have a monitor agent that can do this later on. But for right now, I'm going to invoke this by calling it from the actions palette. I'm going to broadcast a message to the generator to generate. I have to first select an agent. It could be any agent, but it's a good idea to select the agent of interest. And then I will select this broadcast. I've already set the build mode to 3, and I will say test. And now we have a number of particles. We really don't know how many there are. If I do this test again, I'll get more particles. And notice they're not stacking on top of each other. They're only being generated in the cells that did not have a particle. Now, I'm going to save this world, and I would like to have one fixed particle. So I'm going to go to the gallery, one fixed particle, and we'll put that fixed particle where we can see it right up front and save it again. Now, when I reload the world, the build mode is back to 0. When I run it, we see now the particles are all getting fixed in the layer where the fixed particle was. We'll fix this a little bit later. But first, let's color them so we can see what's happening. Well, what do we want to do to color them? What we want to say is that in the particle where the change occurs, we would like it to change the color that's associated with the order in which the particles got stuck. So for the first particles, it's sort of like they're the coldest, and the last particles will be the hottest. So we're going to map the color when we change it according to how many particles have gotten stuck. Well, we don't know what that is. So the first thing we have to do is create a new, we'll call it count, simulation property. I'm going to save it. I'm saving the table. And we're going to say that when a particle gets stuck together, we're going to, in addition to changing it to be fixed, we're going to set @count. Notice we're referring to @count. It's automatically represented in the simulation property table choices with the @ to @count. And again, capitalization is not important, but if you're doing documentation, it's kind of nice that the code actually represents what you've documented. Increment the count. And then what we want to do is we want to map according to what that count is. And I'm going to have to move this up a little bit so that I can change the colors. I want the color to be blue when the count is 0, and I want it to be red when the count is some number. When the count is, the number of particles that are stuck together is basically the number of particles that are in the simulation. Well, we don't know that yet. So we're going to guess right now, and then later on we're going to get very specific. So let's leave it at 100. Maybe there's 50, maybe there's 100. It doesn't really make a lot of difference because the higher the number, the closer to red this is going to get. And when I run it now, I should see the particles change color. Let me single step to see what happens. There's the blue ones. And we can see some purple colors. They're not quite red. And that's because we've underestimated what that particle count is. Well, in fact, if we run it all the way, eventually we'll find out exactly how many particles there are in there. It looks like 45. Well, around 45. Eventually it's going to get stuck. I don't think it's worth waiting at this point. So we see that the particle count, the number of particles is really like around, not 100, but 50. So let's be a little bit more accurate. Let's stop. Let's reload the world. Let's make a new simulation property. We'll call it particle count, part count. And this is a count of the number of particles in the simulation, not the number of particles that are stuck together. And we now know that it's about 50. Well, let's make it 50 and save it. And now when I run the simulation, we'll see the colors get closer to red. Well, why aren't they getting closer to red? Because I have to, now that I've created that simulation property, I need to use it. So what I want to do here is say @part count. Nice to make a tool, but then you should use the tool. Okay, now let's run it again. And we can see that the later ones are red. But we still have this problem that they're sticking together. And why is that happening? Well, if I separate these layers, we can see that they're stacking on top of each other. Well, what we really want is for them to not do that. We want them to move around across the layers. So one thing we'd like to do is to only move on empty cells. Well, we can't quite do that yet until we get rid of the generator agents. And then we'll see a different problem. So let's do that. Let's get rid of the generator agents and see if we can understand what's going on. Well, how do we get rid of the generator agents? Well, we could try to selectively erase them, but we probably eliminate some particles. So let's have AgentCubes do the work for us. Let's go to the generator code, and let's make a new method. We'll call it remove. And all it's going to do is, if this method is invoked, it will simply erase the agent in this cell. And we'll now make a broadcast to the generator to remove. And I will now select any old generator agent, select the broadcast, and say test, and bingo, they're gone. I'm a little reluctant to save it at this point because I might want to make some more changes, but at this point, you got to fish or cut bait. So I'm going to save the world. Well, let's leave the grid there to see what's really going on. Now I'm going to run the simulation. And we'll see that they're all moving nicely, but they're all stuck in that row, in that layer. Well, what happens is the reference is in the particle agent next to at least one cell, but the next two can only refer to agents in that layer. And if I open up the options, we see it was referring to layer, and it says layer 0, relative layer 0. So what I really need is I need 3 rules, each one referring to maybe the layer above me, or maybe it's the layer below me, but I'm next to it if it's in the cell in that column, so to speak, through all the layers. So I need to duplicate this rule and say if it's in layer 1, which means layer, well, let me just emphasize it, layer +1, I will change. Also, if it's in layer -1, I will change. So if I'm a moving particle and I'm next to a fixed particle in the layer directly above me, and that's really in the 9 cells above me, either immediately above me or in the 9 cells immediately around, or in the 9 cells below me or in the 8 cells around me in this layer, I will get stuck. Let's see what happens. And there they are. Now, we've got this grid and we've got the layers separated, but we see it's really going exactly what we want it to do. So let's stop the simulation, reload the world, and now let's make it a little aesthetically nicer. So I'm going to open up the layers panel, reduce the height, and what I want to do is have those particles just barely touching the layer above it. Notice I can go all the way through. It looks like there's only one layer. You can have the particles, even though they're in a layer above, you can have the layer actually collapse. I want them to be just exactly touching. You don't have to be a perfectionist about it. That looks pretty good. And if I erase the grid, we see them all floating in space. And let me now save the world. And now when I run it, let me slow it down a little bit so that it doesn't all go too fast here. We see that it's doing exactly what we want. Tilt the camera a little bit here. Well, to make it even more aesthetically pleasing, let me reload the world. Let's get rid of the default sky dome. And now run it. I should save the world when I do this, so let me save the world. And now let me run it again. And it finally stops. We notice that there's this one white cell, this one white particle that's fixed, that's sticking out. You might want to leave it this way so you can see it traces where was the seed, but we could actually change it to be even better, a little bit more aesthetically pleasing. We'll do that as an example, but I'm going to leave it eventually this way. So let me reload the world. I need to find that cell, which I think is, and I may want to turn the grid on again just to see where it is. As I recall, it was, well, it's somewhere in there. I think it's in this layer. Well, let me run it again and see. There it is. It's this one right here. It's layer 2 near the center. Okay, so let me reload the world. And I believe it's this one here. And I think that's going to be clear because it doesn't see itself as a moving particle. Well, what I'd like to do is I'd like to change it to be black. In fact, just to be safe, let me turn that grid back on and orient it and make sure that I've selected the appropriate particle. I'm going to stretch the layers out a little bit. And I'm pretty sure it's this one. If I select the wrong particle, we see that condition is green. This one, that condition is red. That's the one I want to change. So what I want to do is I want to map it to be black. Turns out the default for the variable in the map is something that doesn't exist, value. And the way AgentCubes works is if you refer to a variable that has not been defined with a value, it's assumed to be 0. If value is 0, I'm going to map it to be black. Now I'm going to select that particle, select that action and say test, and it's black. Now, looking at it this way, we can see that there's a difference. But when I let me go back and change the layers so that they're nice and tight. That's pretty good. And let me rotate it again. Turn the grid off. And you can see it's very hard to see that it's there. So it perfectly blends in with the background. I'll just tilt the camera a little bit, maybe pan up a little bit, tilt the camera a little bit more, and save it. And now what we have is an invisible fixed particle. So when I run it now, things start to stick all of a sudden. And we can't see the first particle. It's there, and it's black, but it perfectly blends in.